In this video, I solve one JEE Main PYQ. This is based on the topics thermal expansion of solids and also mechanical properties of solids. First, let me give a theoretical background that's required to solve this question. Let me take a solid. How to change the size of this object? One way to change the size is apply an external force. Suppose I apply a force like this, say from all directions. So there will be some sort of stretching. So the size of the object will increase. If you apply a compressive force, then the size will reduce. So compressive force means I have to reverse the direction. I have to apply force like this towards the object. So then the size will decrease. There is one more way I can change the size of the object. That's by heating the object. So if I supply heat to the object, temperature will go up. So heat, if I add to the object, then the temperature will go up and size will increase. If I remove heat, that is cool the object, then the temperature will go down and the size will also go down. So if both these effects are simultaneously present, then the change in size will be the sum of these two effects. Let me consider a simple case where the solid is a thin rod. Let the length of the rod be L and the cross section area be E. It's a thin rod of length L and cross section area is E, and there is an external force, say, stretching the rod. Because of this, there will be increase in the length delta L. Now, how to find this delta L? To find this delta L, we know the Young's modulus of this material. This rod is made of a particular material. It will have a Young's modulus that is given as stress by strain. Stress is force per unit area and strain is the change in the length to the original length. So here, since the material is known, Young's modulus is known, applied force should be known, geometry of the rod is known, so E is known, L is known. So from this I will get the delta L due to the external force F. So if this change in length due to the external force, similarly I can change the length by one more method, that's by heating or cooling the rod. Suppose I supply heat to it. The temperature will go up. So the change in the length is proportional to the original length, and also the amount of temperature rise delta T, and the constant proportion is the coefficient of linear expansion of the rod or the material of the rod. So the length of the rod is known and the amount of temperature rise should be known, and this is a material property. Since the rod is of known material, alpha is known. From this I can find alpha due to the thermal expansion. So when these two effects are present, the total change in the length is sum of these two changes. So with this understanding, we can solve the question. So you can read the question. A thin rod having a length of 1 meter and area of cross section 3 into 10 raised to minus 6 meter square is suspended vertically from one end. The rod is cooled from 210 degrees Celsius to 160 degrees Celsius. After cooling, a mass M is attached to at the end of the lower end of the rod such that the length of the rod again becomes 1 meter. Young's modulus and Cushion Phoenix function of the rod are 2 into 10 to 11 meter per meter square and 2 into 10 to minus 5 per Kelvin respectively. The value of M is dash kg. Take G equal to 10 meter per second square. You can pause and run this question. This is a straightforward question. So the change in length, actually here, it's cooling. So there will be decrease in the length. So delta L, when we call it due to cooling, is alpha, original length into delta T. And due to stretching, due to the mass M, that amount you can get Young's modulus as stress by strain. Here the stretching force is the weight of the mass M, which is mg, by cross section area of the rod. Stress by strain is delta L due to the external force, which is M, divided by L. This delta L is due to cooling. Okay, since the total change in the length is 0, because its length is unchanged, delta L due to cooling and delta L due to this mass M should be equal. So this alpha L delta T, which is the change in length due to cooling, should be equal to delta Lm, which is, take this thing here, bring this y down, so we'll get mg by ay and A will go up. So these two should be equal for the net change in the length being 0. So L can be cancelled. Alpha value is given 2 into 10 to the minus 5. The change in temperature, which is 160 minus 210, which is minus 50. We're just taking the magnitude. Change in temperature is 50. That will be equal to the mass that we have to find out. G is 10. Area of cross section is 3 into 10 to the minus 6. And next one is the material is 2 into 10 to the 11. So this you have to simplify. So this 2 into 50 is 100. Okay, let me cancel this 0 here and 10 here. Okay, and then 10 to the minus 5 and minus will become 10 to the minus 11. That will cancel this 10 to the 11. So 10 to the minus 5, this thing can go up here. This will cancel this 10 to the 11. Okay, and this is 10 and this 10 and this is 6. So M will come out to be 3 into 6 is 3 into 2 is 6 and then 2 into 5 is 10. So 16 SI units, so kg. This is a simple calculation which you should be able to do. Sixty is the correct answer. So decreasing length due to cooling is proportional to the original length and the amount of temperature drop, and the constant proportional is a coefficient of linear expansion. An increase in length due to the mechanical load of mass m is from the definition of the Young's modulus stress by strain mg by a by delta L and by L. So from this I get the delta L due to the mass m as mg by a by into L. So since the net change in the length is 0 or the length of the rod is unchanged after cooling and stretching, so these two should be equal magnitude wise. Actually this will be negative because delta T is negative and this is a positive quantity. The sum should be 0. So magnitude wise these two should be equal. So if you take the magnitude alpha L delta T equal to mg by a by to L, alpha is given in the question, length will cancel, L and L will cancel, delta T is 50, mass we have to find out, G is 10, area is 3 into 10 to minus 6, Young's modulus is 2 into 10 to 11 in SI units. So simply you get the mass M as 60 kg.